quadratic function in graph. You did a lot of investigation over the other day. Quadratic cubic. There is something about this cubic that this guy is missing.
It goes in positive y.
Like opposite direction. You have a point there, but that's one. Let's, in terms of this,
It always cut the x-axis.
it always crosses the x-axis. At least once. Worst case scenario, you have this. Right? That's the worst that could happen. But it will cross it. Maybe when coming back, it doesn't cross it. In some cases, you have it both ways. Oh, it crosses every time. But it must cross at least once. But quadratic may not cross at all. Right? In this case, you're going to have complex roots, and both roots are conjugates. That is what this is talking about. Of course, this happens to all of them. And also in this case, remember the significance of this. We'll talk about it in the investigation. What usually leads to this part in your polynomial? In your cubic function, what do you think is responsible for this part that you're looking at?
Quadratic factor with determinant less than 0.
This one. This is what's responsible. The irreducible quadratic factor. That's what's responsible. Okay? So there will be a linear which is responsible for this. Then there will be some irreducible quadratic factor which tells you touch not the x-axis. And that will yield two different roots that are what type of numbers? Say that again. Complex numbers. And those complex numbers will be conjugates. That's what. So these are obvious things that we've been observing, but we never knew their consequences of these things. Alright? So if you have this, if it is odd, you have at least one. At least one means you may have more than one, but you are guaranteed of one. Remember, our quadratic function always look like this, right? Even that may not touch. Do you agree? Even that may not touch the x-axis. If your degree 4 is factorized into two quadratic, and both quadratic happens to be irreducible, then this is what you get. But if you do a polynomial of degree 5, it must cross at least one location. That is the reason for this last observation. Any questions, please? All right, let's move to this question. We are aware that P of x is a real polynomial. It's a cubic. Yes, cubic polynomial. Are you all right, Nick? All right. If you want to stay down, it's okay. It doesn't seem sure you're fine. It's cubic implies that you only have power 3. Then there should be 3 what? 3 zeros. How many zeros is indicated in this question already?
2.
What are those zeros? 1 and 2 plus I. By condition 3, can you determine another 0? 2 minus I. Does that make sense? So which means, since 2 plus I is a 0, so this is how I write, then what can you say? 2 minus I, the conjugate, is also a 0. The implication of this is we can find the quadratic factor, right? Some of these zeros, we did x squared minus sum plus product. You remember that? To find a quadratic expression. That's what we will use because these are complex. So we have to find the sum of the zeros, 2 plus I plus 2 minus I, and that is 4. They are products of zeros. So let me say their sum, so we know that we are referring to the roots, the zeros, sorry, the product. Okay? Their product will be 2 plus I, 2 minus I, and we use what? Difference of 2 squares. 4 minus I squared, which is 4 plus 1. Agree? Which is 5. So what is that quadratic factor? That will be irreducible quadratic factor. Do you agree? The irreducible, of course you don't have to use that adjective. You are going to the quadratic factor. I'm just adding it so you can connect it with these conditions. The irreducible, am I obstructing you guys too much? The irreducible quadratic factor is x squared minus sum of x plus product 5. There's no equals to 0. It's a factor, not an equation. Okay? From here, we have a linear factor. Agree? We have a linear factor. Since 1 is a 0, the last factor is what? X minus 1. Agree? Sorry. Alright. Okay. Okay, so can somebody advise what is the next thing? Especially because of this last condition. What is the purpose of this? P of 0 is equal to 20 minus 20. Because clearly, to me, we have our quadratic, we have our cubic, we could just expand, and our cubic function would have comes out. But does that make this redundant information? Does that make it useless? Can somebody tell me why we need this?
Because usually there's like an A, right?
Say that again.
Usually it's like A bracket alpha.
We need that A. If we just go by this, you are saying the polynomial is monic, which means the leading coefficient is 1. But that's not guaranteed by any condition, right? We don't know yet, so we can't assume that. Okay, so when writing, so P of x is equal to A x minus 1, x squared minus 4x plus 5. Or maybe I put the quadratic first. It doesn't matter. So we expand this. Now if we expand this, because I think we can actually get our A from here directly. This would be AX times A, right? And the constants after the expansion will be what? So this is AX minus A, x squared minus 4x plus, right? So the constant term is definitely what? Negative 5a. And this is your constant term. Do you agree? Because if x is equal to 0, it means every term containing x vanishes. And only the term that doesn't contain x stays. So this must be the constant term. So it means this is actually equal to minus 20. Which means a is actually what? 4. Okay, then the polynomial P of x is actually 4x minus 4, x squared minus 4x plus 5. Then you expand. And if you expand, let's do that. Help me out. 4x cubed, yeah? Mm-hmm. 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 Good. And so our P of x finally is 4x cubed minus 20x squared plus 36x minus 20. Because the question says in expanded form. That's why we have to do that. If the question doesn't say expanded form, stop here. Don't waste the time. Alright? In fact, your 4 should be outside the bracket. That's allowed. Any questions? Are you sure you're alright? I see.
Didn't get enough sleep.
You didn't get enough sleep. So what you keep saying to me happened to you today. Well, guess what? It's Friday, right? So you can get up anytime tomorrow. Of course, don't miss the class.
Oh.
What time is it?
Do we cancel again? If there's something
No, I
seriously
just,
important.
what time is it?
Initially, we always agree on 12. If anything changes, I'll let you know tonight. Because I think I have an appointment tomorrow with the doctor. But I haven't confirmed it at that time. So I need to check with him or her. I don't know if I'm talking to male or female. So once that is confirmed, I'll let you know. If you have anything doing, can you also tell me quickly? Yes? I hope we're not going to meet ourselves in the same hospital. Alright. What time is yours? Oops, so 12 o'clock is not feasible for you. How about later in the afternoon or evening? That'll be too late. Or should we say Sunday? Because I want us to meet one time this weekend. Remember the goal.
No, Sunday school's not open.
Sunday, okay?
Sunday school's not open.
Oh, Zoom. We have a virtual class now, dude.
Sunday I can.
So we don't know, our
I
time is
cannot on
flexible.
Sunday.
We don't do school anymore. What?
I cannot on Sunday.
You're Christian.
Huh?
Are you a Christian? You go to Sabbath day only. So why? No, no.
Oh, it's Mother's Day!
It's Mother's Day.
Yes!
So you want to cook for your mom.
Mr. Daniel, are you
Even though she might end up cooking for you, then you hate it. Then you claim it's Mother's Day. It's actually baby's day, as far as I'm concerned. Okay, so Sunday out because of mommy's babies. Yeah. Let's see tomorrow. I'll communicate with you tonight. Nakita. If we go ahead, okay, how about we all talk later on the group? If we have maybe 2 people saying, I have something I can't change, blah, 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 then we just cancel it and we meet next week. I wish that we don't, but if we have to, then there's nothing we can do about it.
I would rather be before lunch on Saturday.
Say that again?
I'd rather be before lunch on Saturday.